Hello, good day to all my Form 4 students. Today we are here to look at the chapter Rate of Reaction Part 2. In this chapter, teacher going to explain to you how to find the rate of reaction, which is average rate of reaction and rate of reaction at a given time using graphs, where this will be helpful when you are doing subjective or objective questions. Okay, so let's start. So in our previous video, teacher explained to you all how to find rate of reaction from the graph. So in order to find the rate of reaction from the graph, it will involve finding or calculating the gradient of the graph. So please remember, gradient of the graph shows the rate of reaction, whether it's a higher rate of reaction or lower rate of reaction. Okay, now so let's start. Teacher teach you how to find average rate of reaction from the graph and calculate average rate of reaction from the graph for a certain reaction, and also rate of reaction at any given time for another different reaction. Right? Okay, now so let's go to average rate of reaction. Here teacher have given you an example of a reaction where you react hydrochloric acid with a reactive metal where you produce a salt called zinc chloride and hydrogen gas. Now, here teacher would like to highlight the measurable and observable change. Okay, so of course you can measure the mass of zinc. But here for your example, teacher have taken the volume of hydrogen gas collected per minute. Okay, per minute. Okay, so now let's look at how to find the rate of reaction, average rate of reaction. So you have two terms here that you have to take into consideration. First term is, let's look at this, average rate of reaction in the first 10th minute. So this shows that, now one thing before this, in part 1 teacher have explained to you, when you are looking at a graph you should be able to explain where does the reaction stop. Okay, so when you look at the graph, you can see that the gradient is 0 starting from, just say, at the 10th minute. When you're starting from this point, which is the 10th minute, the gradient, you don't have gradient anymore. So this shows that reaction stopped. That means there's no reaction happening. Why? Maybe because the zinc has finished, one of the reactor has finished. Zinc has finished or hydrochloric acid has not enough, okay, not enough to react with zinc. Okay, the amount of particle of hydrochloric acid is not enough to react with zinc. So that is the reason why when one of the reactant is not enough or finished, the reaction has to stop. So now let's go to how to calculate average rate of reaction for the first 10th minute. So if the question asks like this, you don't have to look at anything, just look at the maximum volume of gas collected. So the volume of gas collected is 50 cm cube divided with, can you see they ask for 10th minute. So this is where the reaction stopped. That means you just take the initial to final. In fact, you can say like this. Initial is 0 cm cube minus the final, and the initial time taken is 0 minute minus the time taken to collect 50 cm cube is actually 10 minutes. Okay, so that's the reason why you get the 10th minute. So you will get 5 cm cube per minute. Okay, so this is how you this is how you calculate rate of reaction for average, which is average rate of reaction for the 10th minute. That means you don't have to worry about what happened in the middle. Okay, you don't have to worry about what happens in the middle. You just calculate the initial with the final where the reaction stopped. From there you take the measurement or the volume or time or measurement, anything that is measurable, then you just find the average rate of reaction. But please remember, unit is important when you are writing the rate of reaction, which is technically the gradient of the graph. Alright, now let's go to second type of average rate of reaction. Now here, if you look at it, we are asking average rate of reaction at the 5th minute. So can you see that here the reaction has not stopped yet? So that is the reason why here we have to take the reading of 5th minute minus the reading at 4th minute. Teacher repeat, because at the 5th minute, can you see this? 5th minute. So since you must be careful that the reaction has not stopped yet. So at this time, what are you supposed to do is you have to take the reading of the initial minute, which is 4th minute with 5th minute. Okay, so now, so if you look at this graph, 5th minute, the reading is 30 minus 25, the reading at 4th minute, divided with 5 minus 4. Okay, so this is CM cube, this is minute. Okay, so you will get the answer 5. Again, CM cube per minute. Okay, so sometimes, don't get me wrong, sometimes you might get different answer for both of them. Okay, so depends on the question. Okay, so for this, you manage to get the same answer, but don't get me wrong, sometimes you might get different answer for different reading. Okay, so please remember, if the reaction stopped at 10th minute, for instance, here reaction stopped at 10th minute, that means you must find the average rate of reaction from final to initial to final, sorry. Then when they ask you at 5th minute, you must learn that the reaction has not stopped yet. So you have to take the rate of reaction, that means the reading from the initial 5th minute with the 1 minute behind it, which is 4th minute. So that means you don't care what happened 4.1, 4.2, 4.5 second, you don't, sorry, 4.5 minute, you don't care. Okay, you just take the reading 5th minute and the minute before. Now, so this is what we call by average rate of reaction. Now, let's go to instantaneous. Okay, so another word for rate of reaction at given time. Sometimes in some books they use the word instantaneous rate of reaction. So now, here in this, for teacher to explain this, I used example where calcium carbonate is added to hydrochloric acid to produce calcium chloride, carbon dioxide and water. Now here the observable and measurable, okay, unit here is carbon dioxide. That means you can collect the volume of a certain volume of carbon dioxide. So now if you look at this graph, you will find that the reaction of course will come to an end at certain time. That means literally at 100 second, okay, just say at 100 second the reaction has stopped already. Maybe because calcium carbonate finished, or hydrochloric acid has not enough concentration to react with calcium carbonate. Alright, now, so let's go to at the given time. If teacher can ask you, that means I just specifically ask you what is the rate of reaction at 60th second. Okay, now, so you might be thinking, teacher, this is almost same like average rate of reaction. So average rate of reaction, remember teacher told you, you don't have to worry, you just have to find the initial with final. Okay, initial with final. But here at the given time, you will be surprised to find if falls here, you have to draw a tangent. Okay, so excuse me, if my tangent is not one. So you have to draw a tangent to find the gradient. Okay, if 60 seconds falls here, now the trick is, since I don't have ruler, teacher try to draw straight, you must find the tangent here and tangent here is the same. Okay, so now here you will find the instantaneous rate of reaction is, you will find you get some funny numbers. Okay, you get some funny numbers in order to find the rate of reaction at 60th second. Now, so that means when teacher asks you rate of reaction at 60th second, okay, you will find, just say if here you get X, here you get Y. So rate of reaction is actually, that means after you minus this with this, After you minus this with this, you get a certain number, right? So you can learn that you have this. I hope that you have this previous knowledge from your mathematics. Huh? Okay, so you will find that the rate of reaction is the change of y divided the change of x. So that will be the rate of reaction. Okay, so that will be the rate of reaction, and the just say yeah, rate of reaction is A cm cube per second. Okay, because here per second, so you will find, just say the rate of reaction at 60th second is A cm cube per second. How do you get the A cm cube per second? Is because you are finding the gradient, not like this, not like average rate of reaction. Okay, now here you just find the gradient of the graph, but make sure the tangent here and tangent here is the same. So you have to use a ruler to find the gradient of the graph properly at 60th second. Alright? Okay, now see, so rate of reaction. Now see, can you see the word here, rate of reaction at 60th second? Average rate of reaction as peak minute. Can you see they must have the word average. If average, you know what to do. You just minus the initial with final. Just go 1 second or 1 minute behind it. Okay. Here, average rate of reaction at 60 second. You just have, 60 second is here, but you cannot simply take 60 like this, 80. No, you cannot take like that. You must draw a tangent. Now, if you compare roughly with your naked eye, if you compare the tangent at 20th second versus 40 second at 60 second, if you find the tangent this way, you will find the rate of reaction is highest here. That means rate of reaction is highest at, just say, 20th second. Okay, at the 20th second, so rate of reaction lowest at 80th second. Can you see? Rate of reaction, that means it's literally almost stopping already. So you can find the rate of reaction. Why? Because the tangent becomes less steeper. Okay, so why? Because tangent, or shall we use the word gradient? Okay, so gradient steeper. Okay, the gradient is the steepest, and here is the gradient less steeper. Less steeper. And eventually you get smaller number here, you will get a bigger number here. So that is how you find the rate of reaction at instantaneous, at any time. Okay, because some books they use the word instantaneous. Alright, so please remember, when teacher asks for average, some people have the word average in front. Okay, so don't worry about that. When they ask you for average rate of reaction at 4th minute, so you take the reading at the you minus with 3rd minute. If they ask you average rate of reaction at average rate of reaction, stop. Just say they ask you for average rate of reaction, you take where the reaction has stopped, then you take the maximum volume collected. Now at given time it's a bit different. Okay, so you cannot simply take from the graph and divide it. No, you cannot do that. So you have to draw a gradient. Okay, you have to draw a gradient using a ruler to find the rate of reaction at 60th second, rate of reaction at 20th second, rate of reaction at 80th second. You have to draw triangle. Okay, so it's going to be messy. You have to draw triangle to show and prove. Okay, show and prove the gradient. Okay, you have to draw a triangle to show and prove the gradient at 20th second, 80th second, and 60th second, and so forth. Alright, okay, so I hope you can understand teacher's video. In our next part 3 video, teacher going to continue on rate of reaction. I will be discussing about the 4 important factors that affect rate of reaction, which is very important for this chapter. Okay, so till then, see you all. Thank you for watching.